Chapter 5 Memory, Models, and Research Methods. Here are some of the questions of interest. What are some of the tasks used for studying memory, and what do various tasks indicate about the structure of memory? What has been the prevailing traditional model for the structure of memory? What are some of the alternative models of the structure of memory? And finally, what have psychologists learned about the structure of memory by studying both exceptional memory and the physiology of the brain? There are three processes involved in memory. First, information is encoded so it can be stored in memory. This process is called encoding. Once information is stored, we cannot just let it sit. We have to maintain it or it'll go away. This is storage. Finally, the whole purpose of storing and maintaining information is to use it later. That's retrieval. When I ask students which type of test they prefer, essays or multiple choice questions, almost all students will say they prefer multiple choice questions over essays. So why is that? The difference between these two types of tests captures the difference between a recall task and recognition task. Let's take a look at three types of recall tasks in the next slide. Let's assume that you forgot the grocery list in the kitchen, so you have to recall what was on the list from your memory. This is free recall. After you got back home and you realized that you forgot to buy ground pork immediately after opening the fridge. This fridge was a cue for you to recall ground pork. You decided to prepare pasta sauce without pork. You recall the ingredients like chopped onions, chopped green peppers, and chopped tomato, and the order to add to a fry pan with medium heat. This is a serial recall task. In recognition tasks, you have a list of items you have previously seen, and you are asked to recognize the target item. For example, you are at a favorite restaurant. You love the item you ordered last time you came here, but cannot remember what it was. So you open the menu, see the list of items, and only when you are able to point which one you ordered the last time. This is recognition. Some memories are consciously accessible and others are not. Explicit memory involves conscious recognition of stored information. In explicit memory tasks, participants consciously know they are trying to retrieve information from memory. Implicit memory also involves accessing stored information, but participants don't have conscious access to the memory. For example, procedural memory is required when you need to know how to do something. This is implicit memory, so you don't have conscious access to the stored information, such as the memory required for riding a bike, snowboarding, or touch typing on the computer. There are methods to assess procedural memory includes rotary pursuit task. In this task, you have a rotating disk in front of you with a dot. Your task is to keep the stylus or mouse pointer if you see the disk on the computer screen or a dot on the disk. Another task to assess procedural memory is called mirror tracking task. This may be more challenging than rotary pursuit task, but this is something you can do at home. Here's an instruction. Bring a mirror so you can see the computer screen only with the mirror. Your task is to trace the outline of the shape with your mouse pointer as quickly and accurately as possible. Make sure you don't see the computer screen. The first couple of trials, you may fail miserably, but as you practice more, you will become faster and more accurate. Now we will discuss several memory models: Atkinson and Schifflin's multi-store model, Craig and Lockhart's level of processing model, Baddeley's working memory model, Talving's multiple memory systems model, and McClelland and Rumelhart's connectionist model. First model is called the multi-store model. It is also known as the boxes in the head theory because this model proposes three storages that each of them has different unique properties. After receiving input from the environment, information will be stored in the sensory registers. This box temporarily stores information for a very short time. For example, iconic or visual memory stays here for only 250 milliseconds, whereas auditory or echoic memory can last up to 4 seconds. 4 seconds is pretty long for us to partially process what was said. I bet you experienced this at least once or twice. You are having a conversation with a friend in a noisy environment. When you didn't catch what your friend said, but you realized you actually remembered it before you finished your sentence, sentence asking him to repeat it. That's because your cognitive executive function is seeking information stored in the sensory registers in background while you are engaging in the conversation. Short-term memory storage is used to store information for up to 30 seconds unless it is rehearsed. We use this storage when we need information that requires immediate access. Long-term memory is the permanent memory store that information can potentially be stored until you die. Of course, sometimes you forget something you stored in the long-term memory, but that may be because you lost an access to it, not necessarily because you lost the memory. There are many studies investigating the mechanisms and durations of iconic or visual storage. For example, Sperling flashed matrix for letters for 50 milliseconds. Participants' task was to identify as many letters as possible. With this procedure, called whole report procedure, participants usually remembered only 4 letters. Is it the limit of the number of letters we can remember? He thought the reason his participants' poor performance was not because of the limitation of the iconic storage, but because the iconic memory quickly fades while reporting letters. So he came up with a modified procedure, which is called partial report procedure. On the computer screen, participants saw a matrix of letters for 50 milliseconds, but this time they were told to recall a particular row of the matrix. Sperling found his participants were able to report any row requested. With the partial report procedure, how many letters you can remember depends on when the tone signal is presented to demonstrate recall by writing what they remember. As you can see on this graph, participants remembered 10 letters when the signal is presented 100 milliseconds before the matrix disappears on the screen. But more delays the signal is presented, less number of letters recalled. Now, Averbach and Coriel improved Sperling's work. They asked participants to recall one letter at a time instead of the whole set of letters or rows of letters. First, 16 random letters were presented on the screen for 50 milliseconds. As soon as the set of letters disappeared on the screen, a small mark pointing the position where a letter previously located appeared. Participants' task is to recall which letter had been presented in the position where the mark indicated. Participants were able to recall letters 75% of the time. Therefore, they concluded that 12 letters, which is 75% of 16 letters, can be stored in the iconic memory. So we encounter numerous number of information that are temporarily stored in the sensory registers. But occasionally, there are information that is more important than others. When we attend to the information in the sensory registers, it can move to the short-term memory. If that information needs to stay in the short-term memory, we repeat the information so it can stay for about half a minute. When needed, memory in the short-term memory as well as the long-term memory are accessed. This is the retrieval of information. Generally, our short-term memory can store up to 9 items, or on average 7 items or chunks. Chunking is a useful method to organize information into larger units to expand our short-term memory capacity. So, for example, you may have a hard time remembering the string of 12 digits because it's more than 9 items. But using chunking, we organize numbers into units. In this case, 1980, 1998, and 2003. We now have 3 items to remember. Short-term memory can not only store numbers and letters, but also colors, orientations, and integrated objects rather than just features of them. Next, long-term memory. This type of memory is remarkable because the capacity seems to be limitless, and information can be permanently stored. One group of researchers shows that participants retained information for a very, very long time. For example, participants were able to recognize faces and their names 48 years after they graduated from high school. After 34 years, they were able to recognize faces and names at 90% accuracy. After 48 years, they achieved 80% accuracy for name recognition. We all know recall task is more challenging, but after 30 years, accuracy rate for free recall was still 30%. So, according to the boxes in the head theory, we store information in our head, and what we do about the information determines how long we can retain it in our memory. But we all intuitively know retaining information is not always that simple. For example, my kids kept saying these 5 core values into acronym over and over and over and over at super obnoxious level. But if they were taught to simply rehearsing 5 words over and over, it may not be the most efficient way to remember them. Their memory would even become more rigid if these phrases are accompanied by meanings in rehearsal. These characteristics of our memory cannot be explained by Atkinson and Schiffling's multi-store model. According to Craig and Watkins, type of encoding, whether it is physical, phonological, or semantic, determines how deep the level of processing is. Deeper the level, better the memory. They found that elaborating in rehearsal was better than maintenance rehearsal, suggesting that memory may not be comprised any specific number of separate stores. Rather, storage varies along the line of spectrum in terms of depth of encoding. Unlike boxes in the head theory, where no neurological evidence has been found to support it, information processed at the deeper level shows more blood flow in the left inferior prefrontal cortex. Next, working memory. Working memory is very similar to short-term memory in the way that temporarily stores information. The difference is that the concept of working memory involves more active roles and includes part of the long-term memory, whereas that of short-term memory is more passive, as it is sort of just a box to store information for a short period of time. Working memory has several components. The phonological loop is for auditory information. The visual spatial sketchpad is used to maintain and process visual and spatial information. The episodic buffer is for storage of a multimodal code. It holds an integrated memory of episodes. The central executive is the decision maker in the system. It selects what to focus and what not to focus, switches attention between different parts, and plans sequence of tasks to accomplish goals. Again, unlike Atkinson and Schiffling's model of boxes in the head, there is neurological evidence to support the working memory paradigm. Brodmann categorized the brain area into different sections, and Brodmann's area 40 is the left supramarginal gyrus, which is just above Wernicke's area. This area is found to be responsible for phonological working memory. Brodmann's area 44 is the Broca's area, which is responsible for the rehearsal process of the phonological loop. Brodmann's areas 17 and 18 are the parieto-occipital region of both hemispheres. This area is responsible for visual spatial sketchpad. Evidence suggests that the damage to the right hemisphere produces more severe deficits in the visual spatial short-term memory, indicating that visual spatial sketchpad may reside in the Brodmann's areas 17 and 18 in the right hemisphere. Other researchers focus more on explicit memory and brain organization. Talving proposed multiple memory systems model in which semantic memory stores general knowledge, facts, definitions, and historical dates. Episodic memory, on the other hand, stores event memories such as the first movie you saw at the theater or your 6th birthday. Researchers found some evidence using PET scan that the left frontal lobe is more activated when participants were asked to engage in semantic memory tasks. The right frontal lobe is more activated when they were asked to engage in episodic memory tasks. Here's another model of memory, the connectionist model, also known as a parallel distributed processing model, or PDP. This model proposes that memory uses a pattern of network. For instance, you are looking at rows, and assume there are two inputs which are visual and olfactory. In the network, there is a number of units that receive inputs from the sensory system. What's interesting about this model is that, unlike all the previous models we discussed, PDP proposes that we use the same network to process a different sensory inputs. As can be seen in this diagram, visual inputs are represented in negative, positive, positive, and negative in the first and the second rows, and positive, negative, negative, and positive in the third and fourth rows. Olfactory inputs are represented in a different pattern. When these two patterns are combined, there is a unique pattern that represents rows. So the network in the PDP model is similar to a computer screen you're staring at right now. It can show pictures and videos expressed in millions of colors in one place because there are millions of pixels that turn on and off. As you can see in this slide, I can show different letters using the same space. Now let's take a look at the structure of memory. First, we'll focus on the declarative memory. This is also known as the explicit memory because this consists of the knowledges and memories we have conscious access to, including personal and world knowledge. Explicit memory consists of events or episodic memory and facts or semantic memory. Episodic memory involves conscious awareness of past events, so they are something you remember. It is our personal autobiographical memory. For example, I remember I cut pork ribs and put them in a pan with seasoning last night. Semantic memory involves world knowledge that doesn't relate to events in our lives. So semantic memory is something we know. Example would be, I know how to cook spare ribs. Moving on to the non-declarative memory or implicit memory. This type of memory is the memory we don't have conscious access to. We cannot consciously search implicit memory in our head. Implicit memory consists of procedural memory, which involves skills that are required to do things, such as riding a bike or writing an alphabet on a sheet of paper. Perceptual representation system is associated with priming effects. You are primed with one picture, for instance, and it may have an effect on how you respond later on. This is largely automatic, so you don't have control over this. Classical conditioning is another example of implicit memory. Prior to conditioning, a bell may not mean anything to you, but in the next 7 days, every time you hear the bell, you find a dollar bill on the floor. On the 8th day, you hear the bell again, and you will automatically look down to look for the bill, whether or not there is a bill. This is classical conditioning, which was first studied by Pavlov. Finally, non-associative learning. This includes habituation and sensitization. When your response decreases due to repeated presentation of a stimuli, you are experiencing habituation. Example would be the noise you constantly hear in the background. After several hours of hearing the noise, you may become more habituated. But if the noise bothers you so much, then sensitization may occur. Every time you hear the noise, you get upset. In other words, you are sensitized to the repeated stimuli. There are people with exceptional memory. For example, as studied by Luria in 1968, can memorize a long string of words even after 18 years. Raja Mahadevan can recite pi to whopping 31,811 places and remember matrices up to 20 by 20 digits. You may think they are born with this special ability. Although they may be born with better than average memory capacity potential, they may also put a lot of effort to train themselves. If you are struggling with memorizing concepts and definitions for an exam, there are ways you can improve your memory. You probably have used acronym before, such as I am a tiger acronym we discussed earlier. Method of loci is another technique you can use. Visualize walking around an area with distinctive landmarks that you know well. Then link the various landmarks to specific items to be remembered. When you want to remember the list, you would take your mental walk and pick up the words you had linked to each of the landmarks along the walk. Landmark can be anything, like your body parts, and imagine each of the items hurts each of the specific body parts. Pain is something we have hard time forgetting, so this technique is useful. Only downside of using pain to associate to be remembered items is that it can be hard to forget. I watched a magician explaining this technique on TV decades ago, and my fifth item was can of soda. I imagined myself lying down on the floor and a pile of cans crushing my chest, which was my fifth body part. So I imagined I could not breathe. I still remember this even though it was decades ago. If you use this technique, be aware that it may stuck in your memory for longer than you expect. Okay, next. Memory constructs your personality, right? It is a very important aspect of who you are, but imagine you cannot recall life events after an injury or disorder. Amnesia is inability to recall information acquired prior to or after the onset of the disorder. Depending on severity and type of amnesia, it may have significant effect on your life. Retrograde amnesia is a loss of memory for events that occurred before the trauma. Most common type of amnesia is loss of episodic memory, so comprehension and language may not be lost in amnesic patients. Retrograde amnesic patients may not remember where they are born, who their parents are, etc. Patients with anterograde amnesia, on the other hand, exhibit no memory for events that occur after the trauma. In other words, they cannot store memory forward. So even if they go to the picnic at the same place every single day, it is always the first time they visit that place. If semantic memory and procedural memory are intact, for example, Anterograde amnesia patients may know the path, but they have no idea why they know it. Patients with anomia are unable to recall names of objects. For example, they may be sitting on a chair but cannot describe what it is. Instead of saying it is a chair, they may say, "I'm sitting on a sturdy thing that is made out of wood." We all have infantile amnesia, which is an inability to recall events of young childhood. This may not be a disease or abnormal brain functions. Rather, it may be because our brain is still on the course of development, so it may not have a full capacity to store memory earlier in our life. Okay, here is the last topic for this chapter, Alzheimer's disease. This condition leads to memory loss and dementia in older population. If it affects over the age of 65, patients are labeled late onset. Early onset, on the other hand, is rare, but can affect those in their mid-30s and in the middle age. This early onset is due to the accumulation of amyloid beta plaques. These are deposits of proteins along with clumps of dead neurons. Genes caused to produce amyloid beta protein, and high levels of amyloid beta destroys axons and dendrites. Almost all individuals with Down syndrome will develop Alzheimer's disease if they survive into middle age. Genes have less control for late onset Alzheimer's disease, as 50% of patients have no known relatives with the disease. Symptoms of Alzheimer's disease are gradual, continuous, and irreversible. The symptoms include memory loss, problems doing familiar tasks, problems with language, trouble knowing the time, date, or place, poor or decreased judgment, problems with abstract thinking, misplacing things often such as keys, and changes in mood, behavior, and personality. Okay, so that was the end of chapter 5. Please let me know if you have any questions. Thanks for watching.